assume that means you're all doing your homework and it's all going great. Yeah. 21. 26. Oh, yeah. So this is section 1, 2? 1, 2. Yeah. So this is one about the carpal tunnel and the surgery versus splints. Okay, so the big thing here is it's really difficult to get away from focusing on the wrong thing in statistics. There are always counterexamples to anything, right? There's always a counterexample to something. In this one they said, among 73 patients treated with surgery, there's a 92% success rate. Among 83 treated with splints, there's a 72% success rate. Now here's the part that gets some people confused. Right there, we don't really have enough information to say if it's better to do one or the other. But what does your gut tell you? 92% success rate for those with surgery and a 72% success rate for those with splints.
Surgery.
Yeah, surgery. Now, I am all for bringing up a valid concern about this. If I'm a doctor, there might be something in the condition that tells me, I think surgery is the way you should go. Because if you do this, it's not going to work. I think splints is the way you should go because we don't want to go in there and mess other stuff up. I mean, it kind of depends case by case. But just looking at those success rates purely does those. What's your gut tell you? Which one's better to do? Surgery. Now, it's a 20% spread, so that pretty much is good evidence, but it's still not enough. If I found that there was just, in fact they tell you, there's a 1 in 1,000 chance of getting success rates like those they found in the study. So there's only a 1 in 1,000 chance that it was just randomly, that just happened to pick patients that did better with surgery, right? Because that's possible. True? But there's only 1 out of 1,000 chance. So what's more likely? That it is just a random, holy crap, I just happen to get 20% spread randomly, or that surgery really is better in more cases? Yeah, it's more likely that surgery is better. Does that mean that you should always prescribe surgery then if you're a doctor? No. It just says that that might be your first option unless there's other things going on that surgery shouldn't happen for that person, right? You guys with me? So the questions they ask you are like, should we conclude that surgery is better than splints?
Well, you should suggest it, but
I like it. So you can say it. You can kind of explain your answer. Say yes. According to this study, there's evidence that it's better, right? So a conclusion doesn't necessarily mean that, especially in statistics, a conclusion doesn't mean this is the way it is always. It just means that this is what we see from our study. This is what the evidence points to, right? You guys kind of with me. Some of you, everybody's looking at me, but some of you look at me like, does the result have statistical significance? And that's the 1 out of 1,000 thing. And they're kind of throwing that number around. Later, we're going to be a lot more specific, and it depends on the case. In some cases, 1 out of 1,000 is not enough evidence. So we'll look at that later. Right now, they're saying in general, 1 out of 1,000 is pretty good.
can you go over statistical
Significance.
Yeah.
Okay.
Yeah.
Partial significance.
I know, yeah.
If I, all right, so the thing that keeps going in my mind, there's a problem later in the book, and I really like this kind of problem, where they analyze the scores of people who took a test prep course, like an SAT prep course, and they saw that they scored better. So if, let's say that the general populace scores, what's a good, I don't know, what is it, 980 on the SAT. And, or what is it nowadays? I don't know. Nowadays there's like 3 whole seconds, all this crap. Anyway, let's say this is old school SAT. And the people that took this class score on average 1,080. So a 100-point boost, right? That is not enough information for us to tell if it's significant. So significant means that it's more likely that this has an effect than that this just happened randomly. So if it happened randomly, then I go take another sample and maybe these guys, the sample that I take, they scored 1,010 there and they scored 990 there. Right? Because every sample, are they going to have the same average? No. So here's what statistical significance means. If the data shows statistical significance, that means it's less likely that it's just random occurrences, that it's just because of the way you picked your sample. And it's more likely that there really is a true difference. Right?
Let's do that one more time.
Sure. Statistical significance means that it's less likely that this is just due to random happenstance. You just happen to randomly pick a sample that was worse here and better there. What's more likely, if it's statistically significant, is that there really is a true difference. Now, what do I mean by that? There is a true difference right here, but what are these numbers from? Where did I get this number from? I took a sample. I didn't look at every damn person. I took a sample, right? So one thing that's missing from this data to really analyze it is how big were my samples. If I looked at 3 people here, well, screw you, right? You can't look at 3 people and make a statement based on, take my class, look, they scored 1,000, 3 people, right? That 3 out of 4 dentist thing, you've ever heard of that? 3 out of 4 dentists. Hopefully they didn't only talk to 4 dentists, because then that's not good enough data. Do you kind of see what I'm saying? So, one thing is the sample size. So they don't give us all that data because we don't need it yet. We don't know what to do with it yet. They tell us if it's random, the chances that this happens randomly. If it's 1 out of 1,000 for right now, then that's statistically significant. So that's a little weird for people because they say, that's really small. Well, it's because it's really small. It's such a small chance that this happened randomly. It's a higher chance that it happened because the class actually made them better. Made them score higher. How are we doing so far? And just the idea of statistical significance. Right? Maybe. So a lot of times when you read journal studies, we're going to learn the symbols they use, but they always give us the percentage, the chance that it just happened randomly. Right? So if they pick a group of people and they give a drug to them, and they pick another group of people and they don't give the drug to them, and they analyze how many headaches each group gets or whatever, right? There's a chance that whatever they see happened just because of the people they picked. They're going to get a headache anyway or whatever. But if that's really small, if the chances that the percentage they see are different just by random chance, if that's a really small chance, then it's more likely that the drug actually was different than just giving somebody a placebo or sugar pill. Do you guys kind of get that? No, everybody's looking at me expectantly. Keep talking. Yeah.
So that 1 out of 1,000, that's the chance that it happened randomly. That number is always going to be the chance that it happened randomly.
Yeah, that you got this difference just because of the way the random fluctuations of how you picked your sample, right? So if I go out and I truly pick randomly 30 people, or I come in, I tell you, I just took a random sample of 30 people, and their average height was 7 foot. What would you say about my sampling technique? Do you trust me that I really took a truly random sample? No. Why? Because the chances that happened randomly are so small that you go, no, that's evidence that you're lying. You picked a bunch of really tall freaking people. Or you went and talked to members of a basketball team or something that was saying that sample was not truly randomly selected, right? So that's another kind of way to analyze statistical significance. That's more of a you picked your sample really bad problem, but does that make sense? Yeah.
So this ratio shows the randomness?
Yeah, there's only a 1 out of 1,000 chance that the difference I see is because of the samples I picked. Therefore, what's most likely causing this difference? The fact that these people took this class, right? So it's always competing things. Is there really an effect because of this? Or is it just because my samples were small or I didn't pick them well or whatever?
So the smaller the ratio?
Yeah, exactly. So if this is 1 out of 1,000,000, that's even more significant. That's like, holy shit. It's really, really unlikely that that's just because you happen to pick people that were bad here and good here. It's more likely that there really is an inherent difference.
How is the 1 out of 1,000 chance ratio calculated?
That's the part, that's why they just give it to us, because we're not there yet. starting in chapter 6, we'll start to see how to calculate that. And there's actually a big old table that gives us a bunch of probabilities depending on the situation. Right? And right now that sounds really freaky, but as we approach it, we're going to start learning more and more about where the hell that comes from. And it's not going to be that bad, hopefully, by the time we get there. Right now, they can't tell us a damn thing about where this comes from, because I can throw shit at you like, oh, it's some z-scores from looking at the Gaussian curve. You know, what the hell's that shit? Well, you find out. Okay. So that's a good question. The difference between statistical significance and practical significance is that there might truly be a difference here, but is it really practically worth it? Like if they increase your score by 10 points and it costs $500, and it's statistically said, yes, it really is true because the sample size is so big. Would I pay $500 to go up by 10 points? You know, that's the practical significance. All right, there is a difference, but is it worth my time to actually do anything with this, right? You guys with me? Okay. Cool. Those are the two main types of significances that they talk about. No ET code. Any other questions from? Yeah.
Yeah, section 1.3, number 4, but the last part. It says, what's the practical implication of the result of the survey? Is it just that, like, it's really close to 50%, so wouldn't they have to, like, catch it in the first place?
Who would have to catch it in the first place?
The executives would have to, like, catch the error in the first place.
What's the practical implication? Who do you think would be interested in this study?
People applying for jobs.
Exactly. Not necessarily the executives, because they're gonna do what they always do, no matter what the study says. The people applying for a job, if they knew that 45% of executives won't hire you just if you make a typo on your application, what's the practical implication for you then if you want to get a job there? What are you going to do? You're going to check the hell out of your freaking application. You're going to have like 18 people look at the damn thing, right? That's the practical implication then. So that's sort of related to practical significance. What would you do with this study? What does it mean for you? Right? It's nice to know 45% do blah, but what does it mean for me in everyday life?
But, okay, explain that second part though. What is the 45 value of the statistical?
Okay, so as the 45% value, where did that 45% come from?
Would that be from the people that they...
What does it say? Where did it come from? So what's the difference between a statistic and a parameter? Statistic comes from a sample, and a parameter comes from a population, yeah. And that came from a sample of 877 applicants, so that's definitely a statistic, because the fact it came from a sample. Okay. What's the population on that? What's the population? The sample is 877 surveyed executives. All the executives. In fact, here's the funny thing. This isn't always exactly true, but most of the time you can just take the number out of the way and put the word all in there, right? If I talk about 80 Grossmont economics students that I picked, what's my population? Is my population all Grossmont students? No, because I didn't pick from all Grossmont students. I picked from all economics students at Grossmont, right? So you just take the number out of the way, put the word all, that pretty much covers you for what the population is. This is what I took the sample from. Okay. All right. I've started doing this a lot. I'm always so hopeful. All right. Any other questions before we finish off chapter 1? Yes?
Did we finish 1.4?
I don't think... Let me see. What did I skip? Yeah, I think we did. We talked about discrete continuous. We talked about all the different levels, nominal, ordinal, interval, ratio. And that's it.
So like for the test, you're going to have like vocabulary?
Oh, yeah.
Terms?
I never do define this. I never say define this word. I say identify the following as a nominal, ordinal, interval, ratio. You got to know what the hell it means. And then I remember I asked you to explain your answer too. Because that'll give you a chance to see, maybe you're looking at it differently than I thought myself. And then it does follow what you think it is. Cool. Yeah?
Can you go over number 8 on 1.4 then?
Oh, wait, let me see.
That 1.3 was the nominal.
Yeah, 1.3 is the nominal stuff. Oh, I see. They always trick you.
1.4 is the frequency.
They put the 1.4 at the top of the one page. 1.4 was, we started talking about that, about how you put your names on ballots and how you word questions. And then the rest of it really was just looking at fractions and decimals and percentages. So we looked at a couple examples. Which one, number 8?
Yeah.
So remember this whole section here, 5 through 8, you have to come up with an alternative conclusion, right? Definitely don't say, yeah, that sounds right, because they're wording it so that it's wrong. So number 8 says, a minority group failed the fire captain examination at a much higher rate than the majority group. Conclusion, the exam is biased and causes members of the minority group to fail at a much higher rate. You've got to come up with an alternate conclusion. That's not necessarily true. Right? What else could be going on? What else could cause that to happen? What else would cause a minority group to possibly do worse on a test than a majority group? Training might be not the same. Why?
Because they were part of the majority who got all the major.
Well, what do they mean in this case by minority and majority? They mean minority meaning ethnicity, right? Race. So that's what they mean by that. So you could say that it's not the test, but maybe it was actually the people running the training. Maybe they themselves were biased one way or the other. And they didn't give the same treatment to both groups. Possibly, right? Yeah.
Or it could come from the fact that they have less education than
True.
than the
Possibly a large percentage of them had less education to begin with, and so that it made it harder to get through the training, and then the results on the test showed that, right? So you just have to give me an alternative conclusion that makes at least as much sense as what they say, hopefully more sense than their conclusion. How we doing? Okay. And some of this stuff gets controversial, I understand, because there have been studies that have shown SAT testing is biased. And they've been trying to take that bias out because the people that write it think the way that a majority take it, they don't think the way that some people take it. So they write it in a way that's easier for somebody to understand that's the same as they are, than opposed to those who are not the same. They don't think the same way. And that's not fair. It's supposed to measure your intelligence, not your ability to comprehend somebody else's perspective. Right? Okay. Any other questions? All right, cool. Just to make sure we all get 1.4, let's look at a couple more of these on page 24. Let's do this, and this is always confusing for people. Number 12 says, after the last census was conducted, the census, the United States Census, the Poughkeepsie Journal ran the front page headline, 281,421,906 in America. What might be wrong with that, putting that as a headline?
That might just be citizens. That's not how many people are actually in the country.
All right, that's kind of speaking to the possible problem.
what would be wrong, you said?
Yes.
The possibility that that they have not counted every single person living in
Okay,
America.
cool. So what's wrong with the number they give?
Too specific.
Too specific, too precise, exactly. I have a lot of people point out, and I kind of understand this, they say 281 million, blah, 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 what's? Deer? And I'm like, well, no, it's kind of, I think it's understood that it's a population article, so don't tell me that, right? Let's see, what about number, now this is funny, because this is actually when I put on the survey, and I wanted to see how many people might get tripped up on this. I love it when I ask on the survey, how old are you in months? And I have somebody tell me something like 7. I'm like, really? Wow. It's pretty advanced. You're going through your life pretty quick. So number 18 says, the author surveyed students with this request. Enter your height in inches. What might be 2 problems with this request?
What number is that?
Number 18. So if somebody asks you, enter your height in inches.
To round it?
The rounding won't be too big of an issue, I don't think.
Inches aren't used as much around the world.
True. One thing is you might not really know inches too well. So that's a possible consideration, right? We're one of only 2 countries on the face of the earth that don't use metric system.
England.
Huh?
England.
No, they use metric, yeah. It's funny. We took this system from them. Then we had a revolution. And we said, we hate you, but we're going to keep your system. And based on the size of the king's foot, by the way. Did you know that?
Mm-hmm.
The system of measurement you use is based on measurements of the kings of England, which is interesting. But oh well, too bad for us. So one thing is maybe they don't know inches too well. What else? Does everybody know how tall they are necessarily? Well, that's one thing. Maybe they don't know how tall they are, and they don't want to go check, so they just makes a problem up. The bigger issue is if you do know how tall you are, you normally know how tall you are, as in like 5'8", 6'7". So what could somebody do when they ask for inches? They could miscalculate it, right? And end up with a neat answer like 11 inches tall. I'm like, all right, you're 7 months old and 11 inches tall. What is happening? Okay. This section really, this section, you just have to, it's titled Critical Thinking. A lot of this is more common sense stuff. Like if I have people call in to answer a question and I make them pay to call in, am I going to trust my results from that survey? No. Why?
Because anybody who would pay to answer your question is probably biased.
Could be.
Probably got strong opinions.
Strong opinions, which in a lot of cases tend to go one way more than another, right? You normally have a very vocal people over here, and the other guys are like, well, so what? Yeah, and then you're going to lose the people that really can't afford any extra expenses, right? Possibly. Or people that don't have a phone again, right? They can't participate. Cool. And I love if you go to any of the news websites, and nowadays it sucks that whatever news channel you watch tells somebody your political orientation. That's stupid. But if you go to a news site and they have a poll, you can't trust those at all. Because who are the only people going to answer that poll? The people that like that news organization, for the most part, right? So it's going to be automatically biased. So you can't trust those really too well. Yeah. Oh, okay. And the last little part is just converting fractions to percentages. I'm going to assume you can do this. If you cannot, come see me. Right? Like I said, you hopefully got here the right way, which is passing those other math courses, and part of those math courses was learning that. So you have to know how to do that. Real quick about that, I will give you one little tip. But one thing that always troubles people about percentages and decimals is which way to take the decimal. So if I had 0.0004%, how would that become a decimal? Because right now it's a percentage, right? This is the kind of problem that trips people up, because they think in their head, oh, it's small already, it must be going that way. But here's the cool thing. If you write decimal percentage in alphabetical order, if I want to go from a decimal to a percent, you move the decimal that way. If I want to go from a percent to a decimal, you move the decimal that way. So I'm going percent to decimal, I have to move it that way twice. Once, twice. So I actually have to add on a couple more zeros, right? 0.0000004. There you go. So that's one little thing. Well, most of you guys should be perfectly fine with fractions and percentages and decimals. So the last section in chapter 1 talks about how to collect data. And this is what's missing from most of the newspaper articles, online stuff. Whenever you see graphs and they're trying to make a big deal out of some result they found, they don't tell you, number one, they normally don't tell you how many people they talked to. They normally don't tell you how they collected the sample. Right? So I showed you on Gallup, that's one website. There's a lot of websites that do this. They actually tell you how they collected it, how many people they talked to, and so forth. You don't trust data unless you see that. If you don't see that, you can't trust it. So the first little main thing here is there's two main ways to kind of collect data, and then we're going to talk about breaking those down into further subdivisions. So there's a observational method. You can collect data by observation. And the other main way is through experimentation.
Is this 1.5?
Yeah, this is section 1.5. Now, those should automatically obviously those should be sort of opposites in a way. Which one should you be involved directly with the things in your study? Experiment, right? Which one should those people or things in your study shouldn't even know you're alive?
Observation.
Yeah. So can somebody give me an example like of an observational study?
Throw away the garbage instead of throwing the recyclable
Okay.
trash.
Yeah, you can observe how people throw away the garbage. They just throw it on the ground and not care about it. Just put it in a trash can. And you wouldn't want to do that like talking to them because more than likely the people that throw it on the ground will lie to you. So anytime that could happen, you want to do it by observation. Yeah.
Caltech laboratory where they observe monkeys. Observe them. I mean, they have the probe in their hand.
Oh, I
they
see.
They watch them. Well, it's also experiment and observation because they do both.
Now I want you to be careful. Obviously, in experimentation, you have to observe what's going on. But the main difference with experimentation is you directly influence what's going on. You directly influence what they're experiencing,
No,
right?
they don't influence. They just watch, see.
So have they changed? Will those monkeys act as they would naturally?
Well, no.
Or
they're
are
not
they in a
changing.
strange situation where they have stuff stuck on them that they're not used to having? Yes, see, that's the key, right? Anybody watch Mythbusters? Ever heard of that show, Mythbusters? Yes? It's been my favorite for a long time. Because they do a really decent job of showing you the tables. They talk a little bit about the math they do. The statistical significance sometimes comes into play and all this kind of stuff. I love it. They talk about controlling variables, so forth, right? Small scale, big scale. The one time they did this study, it was really kind of cool. How many of you guys watch cartoons as little kids or still do? You ever see in the cartoon when a mouse comes out and the elephant sees the mouse, what happens? He's scared. This was kind of like an assumed, I thought it was true, and then they're like, well, we don't know if it's true. They really didn't know if it was true. So what they did was they went out to to where elephants are in the nature, in the world. I can't remember where exactly they were. And they put down like, something that looked like just a little pile of dung, something that the elephant would be used to seeing, right? So what they were doing was they were making sure it wasn't that was freaking them out. So when they pulled the string, underneath was a little mouse, right? So here comes an elephant. Now, why would you want to do this using observation alone? That's an experiment. Why? Because they introduced something into the environment that wasn't there, that wouldn't be there normally. Now, there are mice maybe out there. Why wouldn't you want to do that observationally? What would you have to sit there and wait for? Yeah, you'd have to wait for an elephant and a mouse to be close enough to see. And you're like, all right, this is day 17. I don't want to do that, you know? So they have to introduce it. They want to make sure that that only that is what they're seeing, the effects of the mouse. So they put it under this little, looked like a coconut shell, but it looked like the other dung stuff. And then as the elephant came, they would pull it. They first did it without any mouse underneath, just to make sure it wasn't the movement. So you did it a couple times, and the elephant's like, all right, whatever. And then they put the mouse underneath, and they pulled it, and the elephant's like, kind of went around. And that was kind of cool. And that's obviously experiment. So the main thing with experiment is you apply, that's where it's weird with the mouse thing, but you apply a treatment or a change to the environment. Come on, Jeff. And then see what happens. So if you guys, there's a show I watched once because it was on the TV, and I should be more interested in this, but I'm not, where they had somebody pretending like they were drunk, and they were approaching their car, and they wanted to see if passersby would stop them from getting into their car. And then they did it again where the person had a kid, and they were going to the car, and they were seeing, would that make more people stop them or something, right? So if I want to see something like that, if I want to know what would people in a post office line do if somebody in the line started having a heart attack? I don't want to do this because it might take a long for that to naturally happen. Right? I want to pay an actor to go in and pretend to have a heart attack and see what the other people do. So I've applied a change in the environment. Now the reason that treatment's there too is because this is normally drug studies. You give somebody treatment, you give somebody else no treatment, and you see the differences. Observation is exactly what it says. You don't interact with the subjects or the environment. You try to get just the natural actions, right? So if you wanted to see how gorillas act naturally in the wild with each other, what they do, you don't want them to know you're there because then you've changed their behavior. Right? That wouldn't be seeing what they do naturally. You desperately want them to not yet know you were there. Not only for that reason, I'm sure they wouldn't like you being there, but right, you want to keep it natural. You want to keep it yourself out of the equation.
So what would you call? I'm not sure. I forgot the lady's name. The one that has lived in the
But
jungle
Fossey,
for
right? Diane
years,
Fossey.
watching the gorillas and monkeys. You see how in their own habitat. What would that be? Would that be observation or experiment?
Now, at some point, she crosses the line, right? Because she actually wanted to see sometimes how they would react to her.
Okay.
So that's more of an experiment. And the treatment she applied to the way she changed the environment was to introduce herself into the environment. So that was definitely more experimental. Cool. All right. But you guys, I mean, there's a pretty obvious difference there. So if I said you wanted to conduct an experiment to see what people would do at gas station pumps if there was really loud classical music playing, which one would you do?
Experiment.
Yeah, you don't want to just wait for somebody to come driving by in their big old souped out car with their classical music blasting. I don't think that happens too often. And then see what happens. You want to apply. You want to go and start playing really loud classical music and see what people do. Right? Weird study to do, but I just go with what pops in my head. Okay. So now I keep saying that it's really important to have a really random sample. So if in this class, if I took all the guys and I tried to say something about this classroom based on that, obviously that would be a bad sample. Can we narrow down what it means to be then a truly random sample? I can't remember if I've already said this. I might have already said it. What does it mean to be a truly random sample? So why is calling people up and asking them their questions not really truly a random sample? Yeah, everybody without a phone is out, right? So then what does it mean to be a truly random sample then? If an example of a not random sample is you leave some people out, a truly random sample, I love it. There's an opportunity for everybody in the population to be in the sample, right? So officially, the definition of random sample is everyone in the population has an equal chance to get into the sample. So I think I might have said that at one point because we were talking about trying to get a feel for the average time it takes for people to park their cars here on campus. And I said, what if I went out there at 8 a.m. to the parking garage? Remember, we were talking about that. That would definitely be a bad way to collect your sample. If you only did that, what were some ways? We came up with ways to make it better. We said other parking lots.
Go at different times.
More times during the day. Maybe a random selection of days during the week. Right? I mean, I can start to get closer and closer to this goal. It's really basically nearly impossible to always do this. You almost always will leave somebody out. But as long as you can show you're trying to get as close to this as you can then use your study and people will trust your results. Right? Okay, cool. So that's a truly random sample. Let me ask you this. I'm going to try not to spend too much time on this because it's not going to be that important until chapter 7. But they talk about it right here, right now. So if I took if I randomly picked one person from each row in here, right? To make a sample of 1, 2, 3, 4, 5, 6, 7, 8, 9 people. Would that be a random sample? Right? And I'm counting you guys like you're in this row, so everybody's in a row. Would that be a truly random sample? Why not?
Depending on the context, so yes.
No, no. So I don't know what I'm studying. I'm just picking people to study something. And my population is everybody in this room right now, right?
Yeah.
Cool? So I see what you meant. I didn't mean all of Grossman. That would automatically be bad if I only picked from this room. So my population is everybody here. And if I took my sample, one person out of each row, that's a random sample. Does everybody have a chance to be in?
Not
Yeah.
the
Yes.
people that aren't here.
Hmm?
Not the people that aren't here.
But what was my population? All the people who are here.
Oh,
Yeah.
this.
So if you're not here today, too bad. You've taken yourself out, right? So as long as my population takes into account things like that, my population is the people in this room now, I'm golden, right? If I wanted my population to be all my students in this class, how should I try to pick a sample then? Well, it'd be, but I can't just pick it from the people I see. From the roster. Maybe generate some random numbers, throw some dice, come up with a way to do it, put the roster up on the board and start throwing darts, right? Right? Now, there's inherent in all of those, there are biases. Maybe I always throw the dart the same way. There's little things you got to be careful about, but as long as you're trying to go towards a random sample. Now, here's the thing. There's something else called a simple random sample. And this is a little freaky to understand. And people key in on the wrong word in this definition. But I'm going to try, and if you don't quite get it yet, you got time until chapter 7 when it becomes important. If I took one person from each row, could every subgroup of you guys have a chance to be in the sample? Let me say that again. For example, what's one possible subgroup of you guys? A subgroup. One row would be a subgroup. Cool? What's another possible subgroup? Males and females. Another possible subgroup would be by ages, whatever. So all these different ways to break it up. To be simple random sample, not just every individual, but every subgroup has a chance to be in the sample, right? And you guys just said the perfect thing that would tell you what this is. If I took one person from each row, would that be simple random? Come up, tell me, give me a subgroup of these people right here, you guys in this row. You're a subgroup. If I take one person from each row, does this group have a chance to be in the sample?
Yes.
Neat. How do I manage that? I mean at the same time, do you understand? Can these guys be the sample?
No.
If I take one person from each row?
No. One person.
Exactly. So automatically there's a subgroup, this row, or any row really, that can't be all together in the sample. So it's not simple random. It's still random because every individual has the same chance to get in. So simple random is like even harder to make happen. You got to make sure that every subgroup has a chance to be in the sample. If you don't quite get that yet, again, like I said, don't worry, it's going to come up. Chapter 7 is going to be more important. So this is every one has a chance, equal chance, and this is every subgroup in the population has a chance, equal chance. To be in the sample. So if I did it like taking my roster and having random numbers generated or throwing darts at it, would that be simple random?
Could be.
Could all of these people, for example, be in the sample then?
Yes.
Yes, they could be. Could all the men be in the sample? Yes, I could randomly, it could happen. It's very unlikely, but it's not impossible, right? Then every single subgroup has an equal chance to be in that sample. You guys see the difference? So if I broke you down men and women, and I took 10 men and 10 women, is that simple random?
No.
Good, it's not. Because how big would my sample be? If I took 10 men and 10 women, my sample's 20 big. So can 20 women be in the sample? No. So then it's not simple random. Anytime I break my stuff down, like I broke you guys into rows, or I break it down to men and women, the minute I do that, it's not going to be simple random. Because it can't be just any subgroup. It's got to be some mixture all the time, right? A mixture of rows, a mixture of men and women. It automatically excludes it from being this.
So,
Okay.
so that would be correct to assume that if you took the roster and accidentally you ended up with all men, it would still be considered a random sample.
Exactly.
Okay.
So that's the thing people hate about statistics. How often will that happen? Not very. This is why a single study alone is not enough. This is why we hear all the time people automatically say statistics sucks, because they had a study that said, yes, eating eggs is good. And then the next day they said, no, eating eggs is bad. Shit. It's because a single study is nowhere near good enough. It could have been that I just randomly picked people that had some kind of allergic reaction to eggs, and I saw, oh, they're all dying, don't eat eggs. Right? But if I do several studies across the world, if I can repeat somebody else's efforts over and over, then I'm like, well, that looks good. I mean, it's less likely that that happens, right? Do you see what I'm saying? So if I did randomly, I go, oh, it's all men. If I randomly selected again and got all men again, I'm going to start saying, what's wrong with my selection? That's so unlikely that that couldn't have happened. There's no way, right? It's not impossible, but it's crazy unlikely, right? Okay. Okay. Blah, blah, blah. And like I said, we're still in chapter 1. This is the definitions chapter, so it can only be so interesting. I'm trying. The next 3 ways here. This one kind of gives itself away in the name a little bit. Let's see if you guys get this. Systematic sampling. What do you think is true about selecting things from a population systematically? What would that possibly mean?
You have rules for choosing.
There's a set method that you will repeat.
Yeah. There's a set method. Like taking every 5th person that is on the roll. That's systematic. There's a system to how I'm picking. Taking the temperature every 20 minutes. There's a system to how I'm selecting my data points, right? You guys get the idea? Taking every 3rd thing off my assembly line in my factory and seeing if it works. That's systematic. Can you guys see a problem with this method? Number 1, well, would that be random still?
Yes.
Yes, because I can change my starting point. If I take every 5th person, I don't have to start at the 1st person. I can start at the 2nd person or the 3rd person. So everybody still has a chance to get in there, right? So it's still random. What could be wrong, especially with that last example, the assembly line, and let's say I take every 10th thing off this line to see if it works. And if less than 1% are defective, then I'm good. Then it's fine. We can send the whole shipment out. What could be wrong with that possibly?
Yeah, the mark could be wrong. It could be
No, so that's one thing I can't control, is I can only control how I select it, right? I can't control what the other things are doing that I don't select. In fact, sometimes people give me the answer, what's wrong with the sample? Well, they didn't include everybody. Well, a sample never includes everybody, right? You just have to give everybody a chance. So I did. I gave every single one of those a chance, because wherever I started, then I could have started the next one, then they would have had a chance to be in. So what could be wrong with that, though?
It could be a pattern in what you're sampling.
In this case, what could that be made? Anytime there's a pattern in my sampling, in this case, maybe there's like, I always have like either Charlie Chaplin's machinery. Have you ever seen Charlie Chaplin Modern Times? Or I have like cartoons in my head all the time. But like it turns and it goes clamp, and it turns and it goes clamp, and then it turns and goes clamp, and maybe the 10th clamper is broken. So I take every 10th one. I'm like, all right, that's defective. Oh shit, I'm in trouble. When, like you said, I don't realize that every other one is probably okay. Because of the fact that there's a pattern in my sample, and my system actually catches that pattern. Or maybe I don't catch it ever, and I think everything's fine, when actually every 10th one sucks, right? Do you guys kind of see what I'm saying? So that's, these specific ones each have kind of like a situation to be careful. You don't want to use it in certain situations. Systematic, there's a system, a method to how I'm selecting. Calm. Like every 5th person or every 10 minutes. go do something. Yep.
So in systematic sampling, let's say after follow your example, if you pick every 10th item, can you switch it around after a while and go from 10 maybe to 4?
Sure, yeah.
So what wouldn't that be okay though, to do it like that?
That would be fine. Yeah. Each one of these you can kind of mess around with a little bit. Systematic doesn't mean you have to use the same system for the whole thing.
Okay.
You could change your system up. That still doesn't guarantee that you're taking care of patterns in your data, right? Cool, okay. Now the next two kind of, actually there's a quick one I can do. What do you guys think about convenience sampling? Yeah, exactly. Somehow it's easy, which means most of the time convenience sampling, if it's easy to do, I probably shouldn't. I can't trust the data. So for an example of convenience sampling is me trying to say something about all gross 1 students by asking you guys a question. It's convenient because you're all here, and I'm your teacher, so you feel like, oh shit, I better answer him, right? So it's convenient for me to get that data, but is it good? No, it sucks, right? So convenience sampling is like an automatic no. So if I had something due today, something I was supposed to talk to people, and I start talking to people on the way to my class, what do you guys think about this? What do you think about this? What do you think about this? There's my data. That's convenient because it was on the way to my class. I did it really quickly, but did I actually hit my population? Probably not. They're only there at that time, right? So normally convenience sampling doesn't quite target your whole population. And that's why it's easy, because you're not doing the hard work to make sure that everybody has a chance, right? Sort of like standing out there at 8 a.m. at the car garage and saying, how long did it take you? Oh, really? How long did it take you? Okay, well, there you go, I'm done. Right? That's easy, so I can't trust it. No. I can't trust it because it wasn't a good sample. Easy to do. Hardly ever makes for a good sample. Okay, yeah.
Just back to the systematic sampling. So, is this a good statistic if you use the systematic sampling, or?
Only if you can show that your data won't have a pattern in it. You know, so
It's based on a pattern.
yeah, it's based on a pattern. So if your data has patterns in it and your method of selecting has a pattern to it, they might match or not match, and you don't get an accurate feel for what's going on.
So it can work for statistics.
It can, definitely it can. So for example, if I wanted to get people's opinions about some new proposition coming up, and I had a roll of all the registered voters, and I took every 8th person, and I rolled a die to see who to start with. You see what I'm saying? Like I can start with 1 through 6, and then I'm going to take every 6th person, right? So everybody has a chance to be in there. So I roll a 5. So I took the 5th person, and the 11th person, and the 17th person. See, that's fine. More than likely, there's not going to be some pattern just because your name starts with an A or a B or you're next to some. It doesn't mean you're going to think a certain way.
So everybody has a chance to get into that study.
Exactly. But on the assembly line, everything had a chance to get in, but it depends on which one I pick first, because there's very likely a pattern possibly in my data. This is not the best one to use in that case, right? So there are certain cases where this won't work, this hardly ever works, and the next two have certain cases where they wouldn't be the best.
It depends on the study.
It depends on the data. It depends on what I'm studying. Exactly. Okay, how are we doing so far?
One more question about convenience sampling.
Yeah.
You said it hardly ever work, but it does sometimes. Like, let's say, for example, in this class, we're doing a survey just with this class and anonymously. And
Now see, now if my population is this class, so I want to make sure that you guys don't equate easy with always bad. It would be really easy for me to take a sample of you guys and then see what's going on, right? And actually I already did, in a way, because some of you guys filled out that survey. Doesn't mean that is bad, right? And convenience sampling sometimes could randomly come up with a good sample. You just can't say for sure that it did. Right? Whereas with random sampling, that can sometimes come up with a bad sample, but that happens so infrequently that you can trust it if you're doing a random sample.
While we're on this, I have a question for you. You did 2 samples, 2 surveys online. How is one anonymous and the other one is not coming from the same company?
Because one I ask you your name, and the other one I don't.
Yeah, but it's still, you still have the IP address it's coming from.
I am definitely not that.
I'm kidding. I was just.
I got you. Yeah, I'm not. I've got my.
I was looking at asking that how you know what it was.
I got my computer guys right now working to figure out whose IP address is what. Like, this person said something. Let me find out who that is. Yeah, I like that.
Yeah, who is it that thinks they're 7 inches tall and like?
Yeah, who the hell is that? I haven't seen that person yet. Where are they? Did they step on that? No. Yeah, exactly. All right. So the next two I'm going to kind of do at the same time because they are very similar. One of them is stratified sampling, and the other one is cluster sampling. These people get confused very easily because they have the same first 2 steps in a way, the same first step. The first step on both of them is to break your population into groups. Okay. So my favorite example, since we're all in the classroom, is talking about, let's pretend like there are 4 classrooms on campus that actually have students in it, right? So right now there's only 4 classes happening on campus. And that really scares me because it seems like we're headed that way. But so they naturally kind of fall into 4 groups, right? So my population is everybody on campus right now, and we're pretending like there's only 4 classrooms with students in it. Cool? So stratified says the way that I take a sample then is I take a few people from each classroom. I take a few from here, and a few from here, and a few from there, and a few from there. And I put those all into my sample. Step 2, take a few from each to make the sample. So all those go into my sample. Cool. Right? And this is a really good way to do a data analysis when you have subgroups of your population that are tiny, but you still want to represent them. So you might have like only 3% of your students are Native American. So you want to make sure that you take so many Caucasian, so many Hispanic, so many whatever, and so many, and something from the Native American so that everybody's represented in your sample. Does that make sense? So a lot of times it goes across socioeconomic or cultural, ethnic boundaries, stuff like that, to make sure that everybody's got a voice. And very often you do it like if there were like 80 students in here and only 20 in there, very often you would take more from the bigger one. Sounds a lot like government, right? The larger your state is, the more people you send to one of the houses in Congress, right? How are we doing so far? Okay, cool. Cluster, same first step. So you break it up into groups, same like 4 classrooms. But instead of taking some from each, we take all from some. So I randomly select 2. This one is, okay, that one. And I take everybody from here and I make that my sample. So everybody from those 2 classrooms is now in my sample. That's cluster. So cluster step 2, take all from some. Stratified is take some from all. That's one way to kind of put it. How are we doing so far? And I always think about clusters, that weird cereal that's got clusters of whatever. Well, clusters, honey, whatever. Honey bunches of oats? Yeah. And you take some clusters and you leave other ones for somebody else, right? I don't know, some visual to keep these in your head straight, because these are really easy to mix up, obviously. Okay. Can you come up with a reason why? Now clusters are one that students sometimes don't trust, because they say, well, these people, but do they have a chance to be in the sample?
Yeah.
Yes, because I randomly selected from the 4 classrooms. So everybody still has a chance. Are either of these simple random samples? No, because the first step was break them into freaking groups, right? That was the automatic, it can't be simple random, right? Because in this, can all these people be in the sample? No, because I'm only taking some from there. In this example, can this group of people be in the sample? 4 people from me? No, because I only took certain classrooms. Okay, cool. Cluster came into a lot of scrutiny because it was not too long after, I think it was like in 2003 or something, they went into Iraq. Not too long after they overtook Baghdad, and they wanted to see how the neighborhoods were doing. So they broke the neighborhoods down into groups. What they did wrong, they did something wrong and they didn't trust the study, so a lot of people said, oh, cluster sampling sucks. No, they just applied it wrong. They didn't randomly select clusters. They selected the ones that were safest to go to. Right? So then their data obviously is going to be skewed. And they published it and somebody said, wait a minute. And then some people said, oh, the cluster sucks. No, the cluster's fine. They just did it wrong. They didn't randomly select their groups. They purposefully selected their groups, which biases the data. Okay, maybe.
So when is cluster good for what kind of studies?
Cluster is good for when you want to do a study of patients in California, for example, and there's so many hospitals. So you randomly select so many and they just dump their entire patient information to you, right? So that's when it's good, is when you can get an entire big thing of data from somewhere. Or for, what's another good one? If you break it up into zip codes and you go around to houses, you can try to get everybody in those zip codes. It would make it easier to travel, and instead of picking like everything from all zip codes. That travel would be crazy, right? So it's still valid, it's still a random sample, but it just depends on the distribution of your data, how easy it is to get to things. Okay, cool. So they're still both valid, but they have certain situations where you want to be careful about how you apply them. Okay. So let me throw a couple things out at you and see what you think here. Let's see. Let's first do this one, then we'll go back to observation, all that kind of stuff. Let's talk about random, systematic, convenient, stratified, or cluster. Which one of those is this? This is on page 35, by the way, if you have your book. Number 9 says a student of the author collected measurements of arm lengths from her family members. Convenience. Number 9. Yeah. We have to assume that her population was not her family. If it was, then hey, great. But probably not. I mean, that's no good. That's convenient. This always gets people, this gets people riled up. Exit polls after people have voted, and trusting them or not, especially after the 2000 election where they gave the state to one person and then they went to another. Some of you guys were probably, 5 years old or something in 2000? Anyway. Let me see. On the day of the last presidential election, ABC News organized an exit poll in which specific polling stations were selected and all voters were surveyed as they left the premises. Yeah, because they left out entire polling stations, right? But the ones they picked, they took everybody from there. How we doing? Cool. Now, just to answer kind of an earlier question, I can mix and match and modify these methods a little bit. I can do kind of a mixture of these two, right? Like I was saying earlier, I almost said it the wrong way, but now I can say it this way. If I had zip codes and I went and I randomly selected certain zip codes, and then I randomly selected things from in there. And that's kind of like a hybrid of these two, right? I picked certain areas and then I took certain things from those areas. And that's fine. That's a modification of those two. You're not going to see something like that in the book, though. They want to make sure you understand the individual definitions. No, that's too easy. Oh, well, this is too easy, too. Let's see. The Federal Mogul Company manufactures Champion brand spark plugs. Well, that's good to know. The procedure for quality control is to test